In this video, we'll look at how we can use simple naive Bayes algorithm to classify handwritten digit using the dataset called MNIST. So we'll use scikit-learn for this purpose, and yeah, let's get started. So first we need to import some of the libraries that we need. So first of all, we need to import matplotlib, then scikit-learn, and numpy. Those are the three things. Matplotlib, pyplot, then import numpy as np. Then we also need to do import the dataset. So from sklearn the datasets import fetch ml data. Then we'll just use this notebook command so that the plots generated by matplotlib are visible in the notebook itself. So with this, now we can download the MNIST dataset. MNIST equals to fetch ml data. So the data name parameter is original, and if we see what is returned, this MNIST is a dictionary with these 4 keys, like column. It contains column names, description, then data and target. So these two are the ones that we're interested in. So let's just define x as MNIST data and y as MNIST target. So let's just print the data types. And the shape. So the dataset contains the training data contains 70,000 images of single dimensional vector of size 784. In MNIST dataset, the images are of size 28 by 28, and they are grayscale image. So and they are flattened out. So 784 comes from, when we do 28 times 28, it's 784. So the image, it's flattened from 2 dimension to 1 dimension. That's why this is 784. Yeah, let's just visualize some of the training samples for this. I'll just plot a convenient function that I've defined. So let's plot random 20 images. So this will generate an array of size 70,000 with random numbers in between, not in a sequence, but the order is different. So we'll use this, and from this we'll just extract the first 20 ones, and then we'll do plot images. So this plot images, I've just defined this to plot the images in a grid. So yeah, these images and the labels, we need to pass those. So from xp, then since this IMSO is the one that will make the plot the image, it expects the image as a 2-dimensional array instead of 1 dimension like we have. So we need to reshape this into 28 by 28, and then for labels we'll just use the the whatever values from the y. So here we can just see the images. So these are the our whole data set, and it seems the y, the labels are float 64. Let's just do some pre-processing. So we'll just convert the y as type int 32 because they are just numbers from 0 to 9. We don't need it as a float. And also x. So what we are doing here is dividing every number by 255 so that the values lie between 0 and 1. So if we just quickly check x dot min, x dot max, so right now the values, they lie between 0 and 255, but in machine learning usually, especially the neural networks, they like the numbers between 0 and 1. So it's a good practice to do this. So we'll just divide by 255 so our values range from 0 and 1. So now if we check, our values are normalized between 0 and 1. Now before we can make the model, we should split our dataset into training and testing. So scikit-learn already has a convenient function for this. So from sklearn.model selection import train test split. So this function will split the whole dataset into training and testing set. So train x, test x, train y, test y equals to train test split, and we need to pass x and y. So by default it will allocate 70% of the total data set into the training set and the remaining 30% into the test set. So we'll use the training set to train the model and the test set to evaluate the model to see how the model will perform on unseen data set. And yeah, let's just see. So we have now 52,500 samples in the training and 17,500 in the testing set. As we said, we'll be using a naive-based algorithm to classify the digits. So for this we'll use a multinomial I think, yeah. Let's just see. sklearn naive-based import, what else do we have? Yeah, multinomial NB. So we'll just use the whatever default values are there, so you can fine-tune these 3 parameters, but for now we'll just use the defaults. Then to train the model, we'll just call the fit function with the data and the labels. So this is all we need to do. And in scikit-learn, whatever model you make, they always have the same function fit to train the model, and you need to pass the data and label for it. So the training is finished. It's pretty quick to do, and now now we can evaluate our model in the unseen dataset. So there's a function called score. So the score function will take x and y, so and it returns the mean accuracy on given test data and level. So in this case we have test x and test y. So here we can see we achieved an accuracy of 83%. just within using two lines of code, we made a model that can recognize handwritten digit and get 83% accuracy. Now let's try to visualize some of the prediction made by the model, and as well as evaluate how the model performed for each class. So we are doing, since we're predicting 10 different categories, the digit from 0 to 9, we also need to see how it classifies each category. For this, again, there's a simple function in scikit-learn. In matrix, we have what is called as a classification report. Then prediction equals to this.predict, and we'll just give it test x. Then we can just say print classification report with we need to pass the true levels and what was predicted by the model. So y true in our case is test y, and the y pred is the predictions. So we can see these are the categories, these numbers, and these are the score for each category. So basically you want all of these to be higher. So for digit 0, it has a precision of 92 and recall of 91, and using this chart we can see that the model is pretty weak compared to others at classifying the digit 8. So here the score is pretty low, we just have 66, similarly for digit 9. So we should also look at this classification report instead of just the accuracy. Now let's plot some of the predictions. So again, I'll do this random.permutation test x, then we'll take 20 images, then plot images test x p, and we have to resize this to a size of 28 by 28, and our predictions negative dimensions is not allowed. Let's see what I did wrong. It's reshape, sorry, it should be reshape. So the top numbers indicate what our model predicted and the image, so we can see, let's see if we can find any mistakes. So this is clearly 2, but our model predicted 4. And what else we have? Rest of them look pretty good. Let's run it again. 194. So this one is, I think, 1 or 7, but it predicted as 8. And here this is 9, but it predicted as 0. So yeah, we can see another mistake here. And for 4 it predicted 9, but yeah, we have about 83% accuracy by just using 2 lines of code, and the model trained within less than a second. In the next tutorial, I'll show you how to use convolution neural network to make this prediction score even higher. We can reach up to 99% accuracy, so stay tuned.